All right, so let's take a look at this now. This is important when we're talking about absolute value equations. Using algebra or finding out how to solve for x algebraically is really important. So I just want to explain real quickly how to view that. We did the graphic equation right here. This is what it looks like. Okay, but now if we take this equation and we're not graphing it, we're like, how do we approach this algebraically? I do want you to think, the way I'm going to teach this is that I want you to think about this graph, okay, which looked something like this, okay. There's the x minus 3 all in absolute value, and here's the 7, right? Something like this, okay. And here were our solutions. Now, what we learned about absolute value equations is that this section right here on the right side comes from the positive version of x minus 3, right? Of y equals x minus 3. And this side right here comes from the negative version, the negative option, like this. It's literally negative x minus 3, right? So we have two pieces to this. Two pieces. One is like the positive version and one is the negative version. So solving this algebraically actually becomes pretty easy. We're going to take this kind of one instance at a time, and I'm going to choose the positive option for this absolute value, and I'm going to solve for this intersection point first. Then I'm going to take the negative option of this line and solve for this intersection point next. So you have to split it up into two parts. It doesn't matter where they collide, those two. It doesn't matter. All that matters is you want to consider both the positive and negative version. Now, that is the closest to our diagram, okay, that we have that I've showed you there, this diagram, right, or this graph. I want you to consider this though. And actually, maybe I'll teach you this. I'll show you this afterwards. Okay, I'll show you this afterwards. Let's do this one first. So the positive option would be where this absolute value is positive, and that means it doesn't change, right? This doesn't change, it remains the same. And look at this. Now, considering the positive option, I'm just going to solve for x, and I get x equals 10. You add 3 to both sides. And so there, x equals 10 is our first solution, and it's this one right here from this intersection point. See that? Easy peasy. Now, the negative option, okay? So this is where it gets interesting, because we have a negative of our x minus 3. Yeah, okay, so I want you to watch this. Obviously, this negative could distribute into each of those, and you could get negative x plus 3 equals 7. That is perfectly okay. But I want you to notice this, that sometimes it would be easier, instead of distributing a negative sign in, sometimes it's just a lot easier to say, I'm going to multiply or divide by a negative 1. And so you flip the sign on the other one, and then this goes away. Okay? So you have options here. You can actually take the negative value of the expression, the big long one, or you can just take the negative value of the one thing on the other side. That actually works too. So that's the same as the negative option, and this would be easier to do, just plop the negative there. And really, you could plop the positive here too. It's the same thing. So keep your x minus 3, and then just change the sign here on this constant, and then you can solve. So now that we have the negative version, I solve for x, I add 3, and this is where you get negative 7 plus 3 is negative 4. There's your other solution. Okay? Now, just in case you're thinking, that's kind of like a sleight of hand, Mr. Maxwell, that's kind of like cheating. I don't see how we can just do positive x minus 3, take that out, and make this positive 7, and then make it negative 7, and that should work. But it does work, and I'll show you why. Okay, I will draw another graph, and I'll show you why this works. Okay, so let's say we have our graph with just x minus 3. Just x minus 3, because that's what we've considered both times. And let's say I am going to consider where this x minus 3 crosses positive 7, and where it crosses negative 7. This is y equals negative 7. This is y equals positive 7. So guess what? If I flip the signs here, it's just like taking the positive and negative version of the other side, which totally works too. This is 10 right here. and this is negative 4 right here. You see? So you can actually take the positive version of either side and then separately consider the negative version of the other side, because we know that's the nature of absolute values, right? An absolute value means this could be positive or negative inside. So we could take the positive or negative version of either side of the equation. Question?
So if that means that means this absolute value can be moved between two sides of equal sign. If you try to move from one to another, you are like adding a plus or minus to another side.
Yes, in a sense. It's going to get a little bit more confusing when we have absolute values on both sides, though.
Yeah.
So they don't cancel each other out.
Sure.
But so I wouldn't say a blanket statement like that. Not quite. Now, here's another way to look at this. Look at this. I have x squared minus 2x. So that's a parabola, right? That's a parabola. So algebraically, again, you can take x squared minus 2x equals positive 1, which is what we have here, and separately equals negative 1. So here I just, see, they put the negative on this side, you could put the negative on the other side. Oh, it's this second line. You see? So again, the rules stay the same. What comes after this is different though, right? This is now a quadratic. So I actually have this, x squared minus 2x minus 1. And if you can factor that, then great. If it's obvious. If it's not obvious, you might have to use the quadratic formula. Either way, you get your solutions. Okay? Now, when you do this, though, you have to double check everything. Remember how we have to check our work? Okay? You have to double check everything. So double check each answer into your original equation. Make sure that you don't get something funny like an absolute value equals a negative number or something. So you should always check. Okay? And if something doesn't work out with your check, then you have to reject it. So here is the graphical version of this question. So here is the absolute value of this parabola. Notice how it pops back up. And this horizontal line right here has there's three intersection points. There, there, and there. So you could have three answers, there are three solutions like this. You could have two solutions where the line is like maybe up here, only two solutions. Or you could have no solutions. If the line was down here, there'd be no intersection points. So you could have different numbers of solutions too. All right? Okay. Here's another example. Here's another example that is a little bit more complicated. It's not just a constant on the other side, but all the rules stay the same. Okay, so copy this down and we'll do this one together. As you see here, we do have positive version, negative version. It doesn't really matter which side you take it. One side's not easier, right? If we just had a constant, that's easy to put plus or minus. But in this case, we will do positive and then negative versions of the left side here. Okay, so in case one, again, what you want to do, it looks like a quadratic, so let's get everything over to one side. I'm going to try and keep that squared term positive. We're going to subtract an x. This is minus 11x. Add 10. Okay. Now, if you look at that, does it look like you could factor this by sight? Does it? How about x minus 10, x minus 1? Does that multiply to positive 10 and add to negative 11? It does. So I get x equals. Now, remember this. I think some of you making mistakes on tests and quizzes. You have to let each of these factors separately equal 0. So this is x equals positive 10. It's the opposite. It's what makes this 0. Okay? And then here, x minus 1 equals 0. So this is x equals positive 1. So it's the opposite. Okay? Now, we're going to double check these answers in a bit, but let's do the other option. Don't forget about case 2. So here, let's see, we have x squared. I'm going to add x to both sides. So that's going to be negative 9x and then minus 10. Okay. So what do we have here? Multiply to -10, add to -9. Does this work? By sight? Well, I think if we did x, let's see, -10 and then +1, wouldn't that work? -10 plus 1 is -9. -10 times +1 is -10. So we have x equals +10 and x equals -1. Okay, so let's think about this for a second. Could we possibly have 4 different answers? If this was a parabola right here, and this was a, if this was like a V-shaped absolute value line, could we have 4 different values? Let's see, you could have 1 solution. You could have 2 solutions. Could you have more?
Theoretically, you can.
Could you have, well, there's just 2.
There's only 3 because the tens of the same, aren't they?
You could kind of go here, I suppose. 1, 2, 3. So we have to check. We have to check this, because this looks a little fishy. 10. Now do we, 10 and 10 are the same. Okay, so we do have just 3 here. So could we have 3? Yeah, we could have 3. We have to check to make sure this is legit, right? So 10 does show up twice there. So let's check. And again, don't put your values into here. Don't do that, because you're just testing your math from here to here. That's not the point. The point is testing your answers with the original question, right? So don't check by plugging your answers in too late here into your question. So +10, let's see, 10 minus 10 equals 10 squared minus 10 times 10. Does that work? This is 0 equals 0. That looks good. Okay. What about -1? So we have -1 minus 10 equals -1 squared minus 10 times -1. So what's this? This is absolute value of -11. This is 1 plus 10. Okay, so does absolute value -11 equal +11? Or 11 like that? Yeah, that looks good. Let's try +1. So what do we have? We have 1 minus 10, and we have 1 squared minus 10 times 1. So this is absolute value of -9. This is 1 minus 10. This is actually -9. Does that work?
No.
Absolute value of -9 is definitely not -9, right? It should be +9. So this is a problem. Therefore, I would say that this is a problem. Does that make sense?
No, the positive ones are.
Oh, sorry. Where is it? Over on this side. Thank you. The +1 over here is a problem. So we've got 10 and -1 check out. 10 and -1 check out. So the answer is x equals 10 and -1. Okay, that's algebraically. Let's check that. Yeah, let's check it graphically. On your graphing calculators, like I say, if you need technology for a quiz or test, you will be using your TI 83s or TI 84s. So make sure you know how to do it on here. Actually, I'll just pause and give you some. Yeah, okay, thank you. Just put it up there and grab another one. I'll charge that up. Okay, so guys, to find your absolute value function on your calculator, if you want to know, sorry, math, hit the math button, then cursor to the right one. This ABS bracket, that's your absolute value. So you do enter, hello. What? Okay, something's frozen. Okay. All right, so, whoops, delete, backspace, wait, what? Delete. All right, so let's see, math, over to number 1 there. So absolute value, we'll do x minus 10, bracket, and then separately, we'll do x squared minus 10x. And then we'll graph that. Oh, the zoom is all out of whack here. Again, it's in math. Cursor over 1 to the number category. Zoom 6. Okay, let's see. So the window, I'm gonna have to go to the right a little bit there. Let's see how that changes things. Okay, so there's our absolute value of x minus 10, and here we go. Okay, so we have a 10, looks like, over here, and a negative 1. Looks like it's out of screen there, it looks like. Okay, fine. Y max, 220, and then hopefully we should see it. There, and there. That's where it hits. Looks like negative 1 and positive 10. Now, if, so let's, I'm going to copy that. So let's keep this in mind here. Okay. Okay, so this is our graph. Now, what happens if we had the absolute value on the other side? Would you think that would work too? Would that give us the same answers? Well, let's just see here. Okay, so let's delete this absolute value and let's insert absolute value here. Now what? Oh, 2. What is the error? Oh, I see. It wants a bracket there, does it? Fine. Okay, let's see what happens here now. So there's the non-absolute value point. Ooh. What do we see here? We only have one intersection point here. Ah. So this answers your question from before. Is it okay to just say, oh, this is absolute value of the left side. I'm just going to move that absolute value over to the right side. Does it mean the same thing? So this would be, graphically, we would see that it wouldn't mean the same thing because there should be a negative 1 intersection point over here, which doesn't yield us. So it's not the same. You can't just take the absolute value signs and move them over. Yeah? Okay. Good question. That's your answer there. Okay, guys. So please take a moment to look through the key ideas, and there's your assignment. Let me know if you have any questions about anything you see on that paper.